I was fortunate enough today to interview Professor Abraham Loeb, or better known as Avi Loeb. Now, obviously, we're talking about the 3I Atlas, the third interstellar object coming into our solar system. The first 20 minutes of this interview, though, is a little bit about him, some of the frustrations, the misinformation on the internet, which I think is really important to listen to. And then obviously we're going to be talking in depth about the 3I Atlas. And then right at the very end, you're going to be hearing the last 3 days updates, and the third update, which is the 10th anomaly, is going to blow your mind. This is literally within the last 24 hours, so you've probably not heard about it. It's crazy. It's the craziest anomaly out of the whole lot, okay? So enjoy the interview. I really hope you do. And make sure you subscribe because we'll be doing more paranormal content as always, all right? Enjoy the interview. Professor Avi Loeb, I'm recording right now. It's an absolute honor to have you. Do you know what? You're a bit of a celebrity now, aren't you, really?
Not at home, I must say.
Joe Rogan.
I still wash the dishes at home, and actually our dishwasher broke down, so now I have to do it by hand. So that brings me, my wife basically keeps me on the ground, so to speak, and even though I deal with extraterrestrial matters.
Yeah, I bet. But I have to say, because for the viewers, you've literally just come off of another interview, and what I've noticed about you. And, obviously we're going to get onto the 3I Atlas very soon. But I think that you, just purely because you're a professor, you have to be a workaholic, right? Are you a bit of a workaholic? Yes.
Well, I have no choice because we have only 24 hours a day. And I wake up at 4 a.m. typically, and I jog at sunrise. But before that, I usually write an essay, answer. I have hundreds of emails every day now from all around the world. People say that they're inspired by the research, so I feel an obligation to actually fulfill the trust that people have. But I also have amazing opportunities every day. There are new things that come along. That there is a sculptor, one of the most accomplished in the US, called Greg Wyatt, who donated the 51 watercolors and 2 bronze sculptures of scientists, and he will come to unveil those in my office. So he gave it to me at no cost, and it's just generosity that he has. And just a few months ago, I had participated in a gathering. I was reminded of it today because someone mentioned Demi Moore, and I actually spoke with her while walking. And
really?
Margot Robbie was there, and Adrian Brody, and
look at you rubbing shoulders with everybody, hey?
Well, and a week ago, there was a NASCAR car race that I went to because one of the racers decided to put my image and 3I Atlas on the hood of his car.
Wow.
So that was a day after Joe Rogan. So every day or two, there is something unexpected. And of course, the fact that the acting administrator of NASA responded to a tweet by Kim Kardashian forced me to invite her to my research team. Because
I was going to ask you about this.
Very curious about the 3I Atlas. And there was a New York Times article and a Times of Israel article just today about that. So indeed, a lot of interest around the world. But what I find the most rewarding is those emails that say, because of you, my daughter now decided to become a scientist.
Wow.
And because of you, my son now asked for a telescope for the holidays. And that if I can inspire kids to become scientists, they will carry the torch of science forward. And it's extremely important because they are motivated by raw curiosity, in difference from my colleagues in academia that are motivated by showing off, by group mentality, herd mentality, and by ridiculing whatever is outside the beaten path. And it's really unfortunate. And, I had a conversation about that. Yesterday I had 8 interviews, and in one of them...
you had 8 interviews yesterday?
Well, yeah, that's my...
Wow.
Every day over the past few months, I had somewhere between 4 and 8 every day. It's a television, podcast, radio, and newspapers. But in addition to that, I'm trying to do some scientific work, research.
Yeah.
That's what makes me different from many science communicators like Neil deGrasse Tyson or Brian Cox, who are not really engaged with writing scientific papers as much as with communicating to the public what other people are saying in science.
Well, you've
And
tapped into quite a few things about you've name dropped a few things, and you're skimming over some questions I've got.
okay,
But
go ahead.
it's absolutely fine. But did you? Because I am intrigued. Did you expect this? Did you expect this
No,
tidal wave
no,
of that light on you? And
no.
I think one of the one of the reasons, and obviously you know what you know, it's amazing work, but I think that you have this ability to communicate in such a way for us mere mortals to understand.
Well, it's because I'm no different than anyone. I would engage for an hour in a conversation with a plumber that would come to fix the sewer, and I don't feel different because I grew up on a farm, and I arrived at Harvard University just by chance, circumstances. Plan B was to be a farmer. I mean, it's not as
Really?
if, yeah, and I don't I regard science as a privilege of pursuing your curiosity, getting paid to be curious.
Yeah.
And that was what I anticipated when I entered academia. I had this illusion that it's, we are all seeking the truth, and we can make mistakes. It's not about us; it's about figuring out nature. And what do I find in academia? People that are ego-driven, that jealousy is the strongest force that drives them. And this is really unfortunate because we're missing the point, right? And the point of tenure in academia in particular is to pursue questions that are not necessarily popular, to imagine things that involve taking risk. And because perhaps that's where the next discovery will come from. But I don't expect everyone to do that because many people lack the imagination. Okay, so they can't imagine something different than they were already exposed to, and so that's fine. I mean, I have no issue with that. But when they push back and ridicule and try to suppress views that are a little bit more creative than what they are used to, that's harmful. It's harmful for innovation in science. It's harmful to young people who want to pursue science.
Yeah.
So I'm trying to attack this in two ways. One, demonstrate to the public that science is fun, that you can come up with ideas that may end up being wrong, but that's like a detective story trying to figure it out, and the public connects to that relative to a press conference where scientists are telling the public what they should know. And how many times did we hear ideas in press conferences where the scientists were absolutely sure that they're telling the public the correct version of what they believe to be the reality, and then they ended up being wrong? How many times that happened? So the point is, if you pretend to know the truth and tell the public from a higher level of the hierarchy, the public doesn't like that. That's what brings this sense of alienation or animosity towards science. And the second thing is, we are missing an opportunity to innovate, to actually find new things that we haven't thought about before. If we are not, so my basic point is that the foundation of science is the humility to learn instead of the arrogance of expertise.
Yeah.
And the arrogance of expertise is exactly what you would find in those who criticize what I'm doing, and including commentators like Neil deGrasse Tyson or Brian Cox, who are just commentators that are not playing in the field. If you imagine the metaphor of a soccer game, I'm in the field. I can score a goal. They are just sitting on the bench and making statements about what other people, how the players are playing, and who gave them that authority. Like I published by now 12 papers on 3i Atlas. Brian Cox didn't write a single scientific paper about 3i Atlas. He only comments about the fact that it must be a comet. And how does he know? Actually, just now I looked at the latest data, and I can tell you all about it. What looks like a very intriguing evidence about the nature of this object, 3i Atlas.
Now, see, with Brian Cox, I think I can I can feel the passion that you've got towards this. For the people at home, basically, Brian Cox outright said, it's nothing abnormal. It's just a comet. Everybody relax. And I think, for somebody like you that says you've been doing papers on this, you're the one in the field researching this, I suppose it's a bit of an insult, right? For
me, yeah, it is, because the truth is in the details. It's not in statements. I mean, in politics, you can decide, to make a general statement, and it will hold because it's a matter of opinion, right? So you're allowed to have your opinion. In science, the truth is not dictated by opinions. We know that from the Vatican, basically putting Galileo in house arrest. They had the opinion that the Earth is at the center of the universe. It didn't matter because the Earth was moving around the sun for 4.5 billion times before the Vatican even existed. So for the Vatican to say, we believe, or our opinion is that the sun moves around the Earth, who cares? Like, the Earth continued to move. I mean, the physical reality does not depend on what people say about it. Whether we have a neighbor, whether 3i Atlas is technological or natural, has nothing to do with the opinions of people like Brian Cox. It has to do with the details of the evidence. Let's look at that. If there are anomalies, we have to explain them. I don't say that it's necessarily not a natural comet, but we should decide whether it's a natural comet based on the ability to resolve strange things about this object, to resolve the anomalies. And once you resolve the anomalies, you learn something new. So even if it's a rock, I'm here to tell you that it's not a comet of the type that we have seen before. It has all kinds of strange properties, and we can go through them. If you want, I can give you the latest.
But I just also wanted to say, because you're not afraid to lash out a little bit, because obviously somebody else that upset you, and I'm not trying to stir anything here, right? Because you've already said it, all right? But on Joe Rogan, Elon Musk also, I think, raised your brow a little bit by saying about the nickel, right?
Yeah, because he said that indeed there are asteroids that have a lot of nickel, and that's nothing new, that perhaps 3i Atlas has a lot of nickel. Well, the truth of the matter is that it doesn't have a lot of nickel. It basically sheds off, according to the Webb telescope data, about 5 grams per second. At least that was the value on the 6th of August, 2025. 5 grams per second of nickel coming out of it, and out of 150 kilograms per second coming out of it at the same time in other substances like carbon dioxide, carbon monoxide, and a little bit of water. So it's not made of nickel, okay? So he got this wrong. And the second thing he got wrong is that indeed there are asteroids with a lot of nickel, but they also have a lot of iron. You don't find rocks that have mostly nickel and very little iron, because iron and nickel are produced together in exploding stars, and the sun actually has more iron than the nickel. And I was making the point that the anomaly for 3i Atlas is that there was an upper limit on the iron production. It was not even detected initially. So there is much more nickel than iron, and the only other place where we find much more nickel by at least an order of magnitude or 2 than iron is in industrial production of nickel alloys. That was the anomaly, not the existence of nickel, but the absence of iron relative to nickel. And I guess Elon, he was not aware of that, and he responded to the wrong thing and thought that it's natural, but it's not. Because if you find deposits of nickel on Earth, for example, that came from an asteroid impact, you will find a lot of iron there as well.
Yeah, because I think that, as two individuals, Joe Rogan and Elon Musk, having a conversation in the pub, talking back and forth, Elon can give his opinion, absolutely fine, Joe can. But when you have millions of eyes on that, it must be so frustrating when you're saying, oh, hang on a second, be careful what you're saying here, this misinformation.
No. I don't blame them, because both of them are not scientists. Okay, so they are not, well informed about all the details. And if I was there, I would have been glad to give them the facts and provide them with references, to the measurements that were made by the Webb telescope, for example. So, as I say again and again, it's all about the details. It's all about the evidence, the data. That's how science works. However, in today's media, there are lots of influencers. There are lots of people who thrive just by making statements that are unsubstantiated. Okay, and you have a lot of misinformation as well.
Yeah.
I'm trying to establish the narrative in my essays on medium.com, and now I just passed 100,000 followers. So these are not tweets. I mean,
well done.
Tweets are taking a few seconds to read, and there you can get millions of readers. But I'm talking about essays that each of them takes about 5 minutes or more to read, and people are willing to read them. I'm talking about a few million people reading them every month.
Yeah.
And they tell me, they write to me that it's fascinating. I should keep showing them how science is done, because what I'm saying is that it's a process. We don't know the answer in advance. We should not pretend to know the answer. What makes it exciting is the fact that we can learn the correct answer by paying attention to the evidence. And what Brian Cox says is, we pretty much know already what it is. Forget about the evidence. And that's very dangerous, because then we would miss the new knowledge if we assume that everything is based on past knowledge. And I'm trying to correct that, because it's the wrong impression about science. And perhaps that's the reason why, in recent years, there weren't breakthroughs of the type that we had in physics a century ago. I visited Copenhagen for a conference just at the end of August, and as soon as I entered the auditorium at the Niels Bohr Institute, I realized I know this place from photographs of the conferences that took place when quantum mechanics was established 95 years ago. And so I sat on a bench, and they told me, "Oh, you're sitting exactly where Wolfgang Pauli sat at the famous conference where a photo was taken of that auditorium." And the only thing I could think of is, how uncomfortable is this wooden bench relative to what we have nowadays? These people really didn't have a high quality of life, but I would trade everything for being able to go back 95 years and participate in those magical discussions, because those people, when they unraveled quantum mechanics, especially Niels Bohr himself, they did not assume that they know the answer in advance, and they realized that the physical reality is very different than we thought. Now, Einstein was stubborn. He said quantum mechanics cannot have spooky action at a distance, and he had an argument with Niels Bohr. Niels Bohr said, "Look, that is my interpretation, that it's a completely different sense of reality, where things are probabilistic, they are not determined, a system can be in multiple states at the same time. It's not as if there is a hidden variable that the system sits in one state, we just don't know it." And it's really fundamental, and Niels Bohr was correct. Einstein was wrong on that. But what I liked is the openness of mind. And nowadays, even when we deal with physical objects, all these comet experts are entirely convinced that they know it's a comet. If you go back 225 years, before 1803, let's say, these experts of monitoring the sky, they were arguing before 1803 that no rocks can fall from the sky, because it makes no sense. You have rocks on the ground. Why would there be rocks in the sky? And then meteors were found in a famous meteor shower in Liège, France, and a physicist named Bayot popularized this idea within the scientific community. So now they insist that everything in the sky is rocks. And I say, how can you insist on that when we know that we launched technological objects to space, in fact, to interstellar space? And we know that there are 100 billion stars in the Milky Way galaxy, and a fair fraction of them have a planet like the Earth, roughly at the same separation. We assume that we started life on Earth from a soup of chemicals that ended up making intelligent beings like ourselves. So if similar circumstances arose in a billion Earth-Sun systems, analogs, it's really arrogant to assume that we are unique and special. And in fact, alien scientists could have been far more accomplished than we are, our siblings. And it will also give us a connection to the universe. Right now, there is no emotional connection for us. We're dealing with matter, radiation, galaxies, stars. It sounds lifeless. And in reality, what may happen is there are lots of intelligent beings that predated us. Many of them died.
Oh, absolutely.
And our duty is to find them. Instead, what is the mainstream in academia willing to fund, willing to put $10 billion or more in the next 2 decades towards, is searching for microbes. And I say, okay, well, that's reasonable to search for microbes, but we should also invest billions of dollars in the search for extraterrestrial intelligence. Why? Because it might be easier to find. If you have a resident on your street, that resident may throw a tennis ball that you will find in your backyard. That resident may show up at your front door, or might have a construction project in their yard that you can see from a distance. So it might be easier to discover that resident than microbes in the resident's house.
Yeah. Well, I think you've just answered one of my questions there, because something I was going to ask you, and it's almost like I want you to fight your corner here, because what I've noticed with you and many other people, scientists like NASA as well, a lot of people have this, they have a little bit of aggro when a scientist says, we need more funding. It's like, oh, you need more funding. Oh, it's always about funding. Can you fight your corner, please, and explain why you need funding?
Yeah, I have an excellent case, because the public regards the question that I'm asking as the most exciting question in science. And it obviously for a good reason, because it will have a huge impact on the future of humanity. If we find a technological gadget in our backyard that came from a more advanced technological civilizations, it will inspire us to imitate them, to explore space. It will change our philosophical and religious beliefs. It will imply that we might not be at the top of the food chain within the Milky Way galaxy. These are major implications. And moreover, it might require us to defend Earth against alien technology. That's another consideration that may require that we invest $1 trillion a year, comparable to the military budgets that we spend worldwide, in defending Earth by having an alert system of interceptors in the outer solar system that monitors who comes into our backyard. It's sort of like a fence that protects us. We might have to do that if we realize that there is traffic of technological objects. So obviously, the question I'm asking is of great relevance to our daily life, and also of great interest to a huge fraction of our society. Okay, so given that these are the people who fund science through taxes, why wouldn't we listen to their wish and address this question scientifically? And unfortunately, there are gatekeepers. Those are the mainstream academics, the people that decide what they want to explore, who say, no, we will not do that. This is too speculative. It's an extraordinary claim to imagine something as smart as us that built spacecraft. Or no. We will start by searching for microbes. Use all funding towards our highest priority, which is to build a habitable world observatory in the next 2 decades with an investment of more than $10 billion. This is the message of the mainstream. I'm not, imagining that. That's the reality of the situation. Okay, and I'm saying let's hedge our bets. I'm willing to explore microbes. I don't find them inspiring as much as extraterrestrial intelligence, but I'm saying let's invest also billions of dollars at the same time in the question that the public cares much more about, which is, are we alone?
Even my channel, I cover aliens, UFOs. The reason being is, for me, I always say this when someone says, oh, do you believe in aliens? Do you believe in... I say, for me, it's mathematically impossible for there not to be something out there. Right. The universe so huge. It's just impossible, And I suppose, for me, I'm thinking that, and maybe this is a conspiracy theory, but I think that there are people out there, important, powerful people out there, that may actually feel the same, know this, and just want to hide it, and just want to, because they're in fear of what potentially, because of defense and also religion, the implications, having, we know that aliens exist, what the implications on religion.
It's similar to what happened with Galileo and the Vatican. There were religious implications to that. But in 1992, the Vatican admitted that Galileo was right, and that was the worst public relations affair that they had. But I should mention also that there is a manager of a singer in the UK called Ollie Swan. That's the singer, and he's about to come out with a new single this month. And I know that because they asked me for a blurb, and the title of that song is "Aliens Are Real."
Oh yeah, brilliant.
But, let me give you a brief update on 3i Atlas.
Yeah, please, because I'm glad you said that. Because first of all, I do want to say as well, because I want to cut a myth out of there, because a lot of people are suggesting that you are saying that the 3i Atlas is alien, and you're not. You're saying you're not ruling it out, right?
Exactly. I consider it as a possibility.
Yeah, exactly. So I'm glad we said that, right?
And by the way, the reason for this is because reporters that interview me want to get clickbait.
Yeah, exactly.
And so they put titles that imply as if I'm saying that it's alien, but then when you get to the quotes of me, I don't actually say that, but they just want people to check their articles. But then when other people see those articles, they use the distorted narrative.
They feed on it
and attribute it to me, and then get upset about it. But they should get upset at the reporters, not I'm just saying exactly what I'm saying now. And if you want to get my view, you can just read the medium.com, the essays that I put there every day.
Yesterday, I've got it up on the screen now. It's fantastic.
Yesterday I had 3 because there were so many updates. And today I just had 1 that I can tell you more about.
Right. Okay. So let's go back then. For the people that don't know, I know we've gone on there, but I think it was really important to have that little bit of a discussion. Right. From what I can recall, originally there was around 7 anomalies which weren't correct as for your normal comet. Can you explain those
now
again?
There are 10 now.
There's 10 now, right?
Yeah, but I will mention briefly just the main ones, because otherwise we won't have time.
Yeah.
So the first one that I noticed as soon as it was discovered was that it's very bright. And if you assume the brightness stems from reflection from a solid surface, you get that the diameter of 3i Atlas is 20 kilometers, the size of a big city, and comparable to the size of the asteroid that killed the dinosaurs 66 million years ago. So that's an extremely rare type of size of objects. And I calculated there isn't enough material in interstellar space to accommodate delivery of such a giant rock once per decade to the interstellar system. You'd expect it once per 10,000 years or longer. And it's about 1 million times more mass than was associated with Oumuamua, the first interstellar object. So why haven't we seen 1 million Oumuamuas before seeing one like that? And that was the first anomaly that I noticed immediately as it was discovered. And I wrote published a paper immediately after that, a few days later. And the editor, by the way, who is from the UK, said, well, in my paper, the last sentence was, since there is this tension between the mass reservoir of rocky material and the requirement to deliver such a big object to our neighborhood over a period of a decade, one way to relieve this tension is if the object was targeting the inner solar system. Okay. And he said, I'm not publishing your paper unless you remove that sentence. Just one sentence at the end saying, if this problem persists, if the object is not smaller, then maybe it was targeting. That's completely logical.
But why, Avi? Why though?
And then he went to the New York Post and said, this is nonsense on stilts. That's what he was quoted as saying, nonsense on stilts. And I asked, okay, you can have your opinion. This was the early days. We didn't have much data. You are absolutely convinced it's a comet. You think that this is unlikely, that it's technological. But first of all, why suppress other views? And secondly, just using the power of an editor. And secondly, why ridiculing? Why would you ridicule whoever is suggesting that? Especially since I was tenured at Harvard when this guy just started his PhD with a colleague of mine. Like,
really?
Yeah, I mean, I have more than 1,000 scientific papers. I'm much more accomplished than he is, and he dares to say that. Anyway, so it's just frustrating because he held the power of forcing me to remove that sentence. So since I'm a rebel, I immediately wrote the next paper was a full paper on the possibility that 3i Atlas might be technological. A full paper, not one sentence.
Yeah.
So what he accomplished is me writing a full paper and then getting the public extremely interested in the subject.
You back me into the corner. This is what happens.
It went, like completely opposite to what he wished. And then he was trying to basically suppress the public's interest, but it didn't really hold much water because the public is not, the public understands that, there are anomalies and we need to explain them. And it's so in addition to this size anomaly that I just mentioned, or mass, I mean, the object has to be more than 33 billion tons. Okay. It turns out. So I also analyzed like 4,000 data points on the trajectory of the object, and it was losing about 150 kilograms per second, according to Webb telescope data. So just from the fact that it didn't suffer any recoil, I calculated that it has to be that massive, at least 33 billion tons, if not more. Because if it's very massive, it won't be affected much by the mass loss. And then in addition to that, it was going in a trajectory that is aligned with the planets, the plane of the planets around the sun.
Yeah.
And the chance of that happening at random is 1 in 500. So then why would it be in the ecliptic plane, and unless it was, the trajectory was designed by some intelligence.
Yeah.
And it also came very close to Mars on October 3rd. Will come very close to Jupiter on March 16th, and came closest to the sun on October 29th. It also shed, as we discussed about Elon Musk, it shed mostly nickel with very little iron. That's another anomaly. And it had an anti-tail, meaning an extension, a mass loss in the direction of the sun, rather than the way we see it often for cometary tails. The dust and gas get pushed away from the sun because of the solar radiation pressure and the solar wind that are pushing it. So this anti-tail was very surprising. Okay, and I wrote 2 papers trying to explain it. That's another anomaly. There was also a very unusual polarization. Also, the object came from roughly the direction of the WOW signal. Was an enigmatic radio signal from 1977. And so I encouraged radio observers to look at it, and they agreed to do that. And yesterday, there was the first radio detection, the first radio signal from 3i Atlas. It was in absorption of OH molecules. Anyway, the most exciting results are just very recent. So when 3i Atlas passed close to the sun, it was exposed to about 770 watts per square meter. So it was warmed up. The closest approach was between the orbit of the Earth and the orbit of Mars in terms of distance. And from the sun. And that's a significant amount of heat, and it's the kind of stress test that could show the nature of the object. Now, at that point in its trajectory, when it came closest to the sun, it also deviated from a path that was expected by gravity alone. So that means there was some non-gravitational force acting on it.
That's
so that was detected by the ALMA observatory first, but confirmed later. And that non-gravitational acceleration could be either due to the evaporation of matter from a natural comet and giving it a recoil, like by the rocket effect.
Yeah.
Or from some propulsion, if it has an engine, for example. It also became bluer than the sun when it came close to the sun, and it became 5 times brighter than it was before. So the question is, what is going on? And I calculated that in order to get this non-gravitational acceleration, it had to lose at least 10 to 20% of its mass.
Wow.
I did the calculation. So that means at least 5 billion tons.
Wow.
Okay. And I said that's what I said just a few days ago when the non-gravitational acceleration was reported. I said, well, in that case, we should see that mass surrounding it, unbound, and we can figure out if it's a natural object, because if it lost a significant fraction of its mass, we can tell also the nature of the object, because it's not just the skin of the object that gets ablated by the sunlight. So anyway, yesterday there was a first report of an image of 3I Atlas. Now, when it was closest to the sun was between us and 3I Atlas. But again, another coincidence, it was trying to avoid us. Exactly opposite, the solar conjunction occurred in the same, week, just a week before it came closest to the sun. Closest to the sun for a spacecraft is the optimal time for a maneuver. Okay, and indeed it showed some deviation there. So when it was behind the sun, we couldn't look at it from with telescopes on Earth. But there were some other telescopes in orbit around the sun that realized that it's actually getting bluer than the sun, which is surprising because it's a cooler body than the sun by a factor of 20. So it should have been redder than the sun. Also, dust usually makes it red relative to the sun. And so at any event, by now it's 30 degrees away from the sun, so we can observe it. And the first image yesterday by some amateur astronomers revealed that it has a very complex series of jets coming off it, at least 7 of them.
7 jets coming okay, and this is crazy. You've gone through these anomalies, and there's so many questions I have to ask about these anomalies. But let's just talk about this major update about these 7 jets. What's going on there?
The 7 jets could either be pockets of ice on the surface of a natural comet, and then the ice gets sublimated by the illumination from the sun. However, if you look at these jets, some of them are pointed towards the sun, as you might expect. Some of them are pointed away from the sun. So, there is, again, this strange behavior where you have jets from everywhere, even though the sun illuminates just from one side. Now, the object is indeed rotating over 16 hours, but you might expect as soon as it goes to the night side, some of those ice pockets, they get frozen immediately. We calculate. So why do they maintain themselves? Now, at any event, we see those jets from both sides, and they seem to be steady. They seem to go far out. Now, it could also be...
Sorry, Avi, is it too early to see if these are moving this 3I Atlas around with each jet?
That's obviously the origin of the non-gravitational acceleration. So the question is, are these thrusters that are of technological origin? And today there was a new image released, again by amateurs, that shows the large-scale structure of these jets. Turns out that they extend, and I just analyzed it in the last few hours. They extend, and that shows you how much fun it is to be a scientist. Because just from this image, now the observers reported the image. They don't reach any conclusion, any inference. They just say, we see all these jets. It's interesting. Some of them are pointed at the sun, some of them away from the sun, and the ones that are away from the sun, they extend all the way out to a very large distance of order half a degree, which is the diameter of the moon or the diameter of the sun. The
Wow.
half a degree is huge, and it corresponds to 3 million kilometers. Okay, so in the anti-sun, in the opposite to the direction of the sun, it extends to 3 million kilometers, the jet, and it's highly collimated, by the way. It's not as if it looks like a fan, and towards the sun, you can see jets that extend to a third of that distance, about 1 million kilometers. Okay, so then I said, okay, well, what stops those jets in the direction of the sun? It's obviously, they should be more powerful than the solar wind, because they wouldn't go that far if the solar wind was stopping them at a smaller distance. Okay, so the solar wind carries some flux of momentum, and the jet needs to carry more flux of momentum, at least out to 1 million kilometers. So I basically balanced it's called the ram pressure of the solar wind with the ram pressure of the jet going towards the sun, and I realized that the amount of mass being lost over a period of a month by this network of jets is of order 50 billion tons.
What? So that's what? I mean,
so that means the object is more massive than that, because something survived. So that means the object is as big as 5 to 10 kilometers. It's at least, if the core of the object survived, if it was not decimated, it was not, because we see it continuing to move, right?
Yeah.
So it must be of order 10 kilometers. That's the kind of diameter you get. And this is very massive. It's the size of a city.
Yeah.
Now, this brings me back to the first paper that I wrote, because the only caveat in that paper was, maybe we get the size of the object wrong. Maybe it's much smaller.
Yeah.
Maybe it's less than a kilometer. In which case, the mass is proportional to the size cubed. So if it's less than a kilometer, it's 1,000 times less massive, much more reasonable. But now, from the mass flux in those jets, I get that it must be significantly more than 50 billion tons. So that means, of order 10 kilometers, 5 to 10 kilometers in diameter. So then the question is, how is it possible that such a giant thing arrived to the inner solar system over the past decade? As I said, there isn't, if you just do the math, you would expect it once per 10,000 years if it's material from planetary systems, even if you package all of the material in there. So that says that the chance of seeing this giant object just from processes we understand, in interstellar space would be, less than 0.1%, if we were to package all the material in interstellar space into such big packages. But if you assume that there is the same amount of mass in small packages as in big packages, then the probability for that is 1 in 100,000. Okay, and then on top of that, you add the fact that it lies in the ecliptic plane of the planets, which has a probability of less than 0.2%. And altogether, you get a probability of 1 in 100 million.
Wow, this probability is just getting smaller every day. It's getting smaller and smaller and smaller.
Well, now we have much better data. And, previously, we didn't really know the size of the object. So I'm saying, if the known processes that would distribute rocks in interstellar space from materials available in planetary systems have a chance of 1 in 100 million of bringing us 3I Atlas, then obviously it's anomalous, right? So then, of course, the amount of mass lost from the object is much smaller in the case of technological objects, because then, chemical rockets have an exhaust speed that is at least a factor of 10 higher than the volatiles that get sublimated from the surface of a comet. And if you use ion thrusters, you can get another order of magnitude. So just the technologies that we use for propulsion can give you a mass that needs to be lost that is 100 times less, only 1%. Of what a comet needs to lose.
Right.
And that means it means that the fuel can be less than 1% of a spacecraft. Now, in addition, of course, any alien technology might use propulsion that is far more effective than ion thrusters.
Yeah.
I mean, and in that case, of course, it will be even smaller, the amount of fuel that you need to eject. So how do we figure it out? It's very easy. In the coming weeks, we can measure the outflow speed of the jets.
Okay.
We can measure the composition of the jets, and we can measure also the amount of mass in the jets, and from that we can infer whether the natural explanation or the technological explanation appear more likely. And I'm just saying, let's just measure those things using spectroscopy from the Webb telescope, the Hubble telescope, or from ground-based telescopes. I don't care. But the beauty of what I'm describing to you is that I have a very clear test, one way or the other, in terms of the amount of mass involved, the velocity of the outflow, in the context of a technological versus a natural object. And we can figure it out based on upcoming data, rather than say we know it's a comet, the way that some of the commentators or influencers say.
So you, a while ago, this was right near the beginning, actually, you put a table together from a category of 0 being insignificant, basically a comet, to 10 being confirmed technology, global impact, confirmed extraterrestrial, artificial origin, impact, trajectory, global terrestrial consequences. You previously, from what I remember, you ranked this from 0 to 10 at number 4.
That's true.
Now, has it moved around since there? Are we going to get into a 50-50 now?
Well, this is called the Lobe scale now, because there are 3 papers discussing it.
Oh, wow.
And I'm waiting for the upcoming data, because it will be foolish of me to either bring the rank down to 0 or elevate it to high values if within a few weeks we can collect more data about these jets. And so it should be very interesting to analyze the upcoming data. Let's see what it brings.
Yeah. Okay. Well, because there's a doctor. Forgive me if I've pronounced his name wrong. Dr. Michio Kaku.
Yes.
He actually just came on the internet, and he basically said that the reason why it's showing these strange materials is because it's 7 billion years old and it's picked up garbage.
Well, again, he didn't write a single scientific paper on this subject. He's also a commentator, and he's again trying to be liked and popularize science. It's not as if he's saying that based on any calculation. I wrote a paper with a student of mine where we said, suppose it's a natural object, and we were to integrate the trajectory back in time, what kind of stars it should have originated from. And of course, we found that it should have arrived, because it was moving, when it entered the solar system, was moving at 60 kilometers per second. That's a high speed. We found that it should have arrived from the population of old stars in the Milky Way disk, because those stars were kicked around for a longer time, so they have a higher characteristic speed relative to the sun. And so indeed it should be an old object if it's natural. But even for that, whatever Michio Kaku is saying, even that has a big caveat that he does not even recognize, and that is in associating the object with a parent star, you are assuming that it inherited the velocity of the star. But in principle, it could have had an ejection speed from the planetary system around the star. So if the ejection speed is large, the star may have a small velocity, and it's just the ejection speed that was large, bringing it to the speed that we observed. So even saying that the speed indicates an older population of stars has a big caveat to it, and that is this assertion ignores the ejection speed being potentially large relative to the speed of the parent star to start with. So if you ignore the ejection speed and just say that the object inherited the parent star's speed, then it must have been an old star. So there are two things coming in: the neglecting the ejection speed in the calculation, and secondly, assuming that it's a natural object. Because if it's technological, the speed would have been related to the propulsion system.
Yeah. Now, also, another frustrating thing for you at the moment, I would imagine, and for a lot of us, is the release of the photos from NASA, right?
Oh, yeah, they haven't released it. And I don't believe that they're doing it on purpose. I think it's just some bureaucratic rule that they have not to release it until the government shutdown ends. And it's really unfortunate because we don't want the politics of the day to suppress progress in science. I mean, they have the data. They should have shared it with the scientific community. It doesn't require a lot of effort. Many of the scientists involved with a high-rise camera on board the Mars Reconnaissance Orbiter, many of them are not NASA employees. Okay, so there must be some bureaucracy within NASA that says you're not allowed to release it until we approve it, and the office that approves it is not working because of the government shutdown. But I should say the acting director of NASA, Sean Duffy, responded to a tweet by Kim Kardashian.
Yeah.
When and that was at the same time that I approached the team, and also Representative Anna Paulina Luna wrote a letter, letter to Duffy asking for this data to be released. So I didn't get a response, and my point is that there should be a higher priority given to science versus politics, especially when dealing with important data that could guide us as to how to observe Terrestrial in the future. This is the highest resolution image we have in terms of it having 30 kilometers per pixel, so it's 3 times better than the Hubble image.
Yeah. It's strange how, like, in my world, you should all be working together, communicating at a high standard,
Right.
And and this is why I think the conspiracy theories are built, because it's like, well, why? If you've got the images, just release them.
Right. Yeah, but I was asked about it and whether they have some evidence for extraterrestrial intelligence, and I said that it's most likely due to terrestrial stupidity than extraterrestrial intelligence.
Right. Okay.
It's politics overruling science, basically.
Yeah, and now I also saw that when it went behind the sun, there was lots of large solar flares. Is that normal? Is it anything to do with the 3i Atlas?
Yeah, I wouldn't assign an important significance to that.
Okay.
But if we detect, for example, a large maneuver, or we detect artificial lights like the blue light that was implied when it came closest to the sun, or if we see for example, a hotspot on the object that implies some hot engine, or any of these constitutes technological signature. And the observations by the Meerkat Radio Observatory in South Africa, they are operating at a frequency that is very close to the frequency of the WOW signal that was discovered in 1977. So I'm happy they're doing that, and hopefully we'll see the full results in a scientific paper.
Yeah, and also I saw that there was another comet that appeared.
Yes.
And then disappeared. Has it recently
disappeared?
Not really.
This
is again. This is where I want to just clear the muddied waters, and just.
Well, so it appeared around. It was discovered on November 2nd, and this one actually is just marginally bound to the sun. So it's on the borderline of being an interstellar object. But it could have arrived from the Oort cloud, the outskirts of the solar system. And the fact that it was noticed, just after 3i Atlas came to perihelion, closest to the sun, just a few days later, raised the possibility that maybe we're dealing with a mothership that released a probe.
Yes, because you mentioned about probes, didn't you? Potentially being
And I did a calculation that indicates that this object could not have originated from 3i Atlas unless it has some means of propulsion.
Right.
And obviously we haven't seen it long enough to figure this out. But if it's just moving on a gravitational trajectory, it actually is unrelated. because its trajectory is perpendicular to the one from 3I Atlas. It's at about an inclination of 110 degrees. So it's very high inclination, whereas 3I Atlas is inclined by only 5 degrees relative to the plane of the Earth around the Sun.
So for you then, what's next within the next few weeks?
Oh, yeah. So studying those jets and figuring out their speed, their composition, their mass flux would tell us everything about this object, whether it's anomalous, cannot be explained as a natural comet, or whether it's completely reasonable within the parameters of a natural comet.
Yeah. And then finally, I suppose these anomalies that I say we have nothing to do with it that you've noticed. How different are they in comparison to ʻOumuamua and Borisov?
Oh, very different. Borisov didn't have much anomalies because it looked like a comet familiar to us. ʻOumuamua didn't show any gas or dust around it, in difference from Atlas. There were no jets, there was no material evaporating from it, but nevertheless, it was pushed away from the sun by some mysterious force, and it wasn't clear what's doing it. And in addition to that, it was most likely flat in its shape. It had an extreme shape because the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. So very different from 3I Atlas in its shape. Also in its size, it was of order 100 meters, the size of a football field, compared to 3I Atlas, is the size of a city. Just compare a football field to a city. So very different anomalies. But my point is, out of the 3 objects that came into the solar system from interstellar space that we spotted over the past decade, 2 of them have anomalies. So that's great news. Why? Because it either represents some new knowledge about astrophysical factories of interstellar objects that we were not thinking about, that make objects different from what we are used to in the solar system, or maybe they represent technologies that we don't possess. And, in both cases, we will learn something new.
Do you think this is going to be a once in a lifetime? Or do you think because we've seen now 3 of these interstellar, do you think we're going to see more of these strange...
Many more, because there is a new observatory called Rubin in Chile that was inaugurated just in June 2025, a few months ago. And it employs a 8.4 meter aperture and a camera with 3.2 gigapixels that surveys the southern sky every 4 days. And we expect it to discover an interstellar object every few months. So we're entering a new era in the next decade where the Rubin Observatory will give us many additional examples.
Brilliant.
And it's an opportunity to check if each and every object is a rock or maybe something else. And I wouldn't be surprised, if we will eventually realize there is something else out there.
Oh, absolutely. And Avi, I really appreciate everything, because I understand and I can sense and I can hear that you are literally punching through walls to get this message out there, the correct message, right? And you must be going through quite a bit underneath all these interviews and the smile faces. So I really appreciate you spreading the word out there and keeping us informed.
Thank you. Well, the main point, it's not about me, it's about the interstellar visitors coming to our backyard, and let's focus on them. Because it's exciting, it's fun to do science this way, where you're open-minded and you pay attention to evidence.
Well, you're a busy man. I'll let you get off. But thank you very much, Professor Avi Loeb.
Thank you. It was a pleasure.